Hello everyone. This is for the, as you can read, the Algebra 2 Chapter 1 practice test. Remembering that when you guys are evaluating a function, one way that you can approach this is write the expression without the variables, parentheses in place of the variables, and then just fill in the numbers. Wherever that says R, you put a -2. So a -2 goes there, a -2 goes there, and a -2 goes here. And then wherever it said S, you put a 7, so a 7 goes there. And a 7 goes there. I don't know why I hesitated. I apologize for that. And then you just type the thing in your calculator from start to finish. Don't bother stopping and evaluating it along the way. Just type it in from start to finish. Okay? This one, you're just distributing this in. So you'd have 2x minus 2 minus 13x plus 13. So you'd have minus 11x plus 11. This one you're solving, remember you're just working with PEMDAS. When you're solving an equation, that you're going to go up PEMDAS, solving stuff in the reverse order that you evaluated it. So you're going up. So you start by adding the 45, you're undoing adding and subtracting. So you have 45 is equal to 15 over 8y. This is held by multiplication. It's a fraction that's being held by multiplication. So multiply by its reciprocal. You're welcome to just type this in your calculator, or I can do this in my head. That reduces to 3. So your answer is 24. Okay. Same thing with PEMDAS. You're staying there. So I'm going to add the 2x over. So you have 3 is equal to 3x plus 8. And then subtract the 8. So you have minus 5 is equal to 3x. And then divide by 3. So you have minus 5 thirds is equal to x. And you're done. This one, you need to distribute this inside first. Distribute the subtraction through. So you have 21 minus 28x is equal to 5 minus 4 minus x. That subtraction distributes through. I'm going to bring the 28x over to the side. So I've got 21, this is gone, equals 5, oops, let me erase that. 5 minus 4, I can take care of that. 5 minus 4 is 1, minus x plus 28x is 27x. Subtract the 1, and I've got 20 is equal to 27x. Divide by 27. And you've got 20 27s. And I don't believe that's going to reduce, because 27 is only made up of, 3s. And there's no 3s hiding inside the 20, so that's as good as it gets right there. Okay? Solving for for p. I apologize, solving for p. So this stuff all needs to go away. All of that is held by multiplication, so just divide it out all at once. Sorry, that's an n. Looks like a p, doesn't it? Okay. So you'd have m over 2n. Good grief. Charlie Brown. All right, n squared. My n is looking awful today. Was p. Okay. Solve for d. You could distribute this in, but it's held by multiplication, so you might as well just get rid of it. So I'm going to multiply both sides by 3 7s. Yeah, so we have 3c over 7 is equal to, because that just multiplies across. And this is gone because it canceled out with that. D minus 21. Add the 21 over. Equals D. This one is exactly the same thing. I'm going to get rid of the 5 9ths by multiplying by 9 5ths. And you have 9c over 5 is equal to, and this cancels out, f minus 32. Now add the 32 to the other side, and you have 9c over 5 is equal to, oops, I got carried away, plus 32 is equal to f. When you're solving an inequality, there's something you got to watch out for, but on this one, I'll tell you about it when we bump into it to remind you. Okay, this is no big deal. I added the 10 over. Oops, I wrote equals. Less than 31 divided by 3. X is less than 31 thirds. Okay. Here, I'm going to add the 2b over. So I have 13b minus 5 less than or equal to 6. Add the 5. And you have 13b is less than or equal to 11. Divide by 13. Okay, there you go. If you had decided to approach this by taking the 11b to the other side, just to warn you, rather than warn, how about remind you, how about that? So I have minus 13b plus 6, subtract the 6, minus 13b. At this point, when you go to divide the negative 13, remember, you have to turn the inequality around. It's called changing the sense of the inequality. It's called changing the sense of the inequality. Sorry, guys, I had that turned up loud. You have to turn it around whenever you multiply or divide across the inequality with a negative number. Okay? And that gives you the same answer you had for the previous one. I mean, I took the x's the other way, or the b's the other way, so I didn't end up with a negative. So this one, remember, you have to distribute that in. So 5 plus 5x greater than 1 plus 3x. If you take the 5x to this side, you're going to get the negative values for x, and then you divide out the negative, which means you got to turn the inequality around. It's not that that's wrong to do it that way. I'm just looking ahead and going, you know what? I don't feel like doing any more work than I have to, so I'm going to subtract the 3x to this side and avoid that whole dividing by the negative thing, having to turn the inequality around. You know, it's just, yeah, it's not that it's wrong doing it the first way. I'm just doing it to avoid it. 1, and then subtract the 5. So you have 2x is equal to negative 4. Divide by 2, and you get negative 2. Okay? When you have a double-sided inequality, you start the same way. If this wasn't here, you'd start by adding the 12, wouldn't you? Or if this wasn't here, but the other side was, you'd start by adding the 12, wouldn't you? Yeah. Okay, well, you're just going to add it to two sides now. So I got rid of it here, so I have to add it to the 15, and I have to add it to the 3. So I've got 15 less than or equal to minus 6x less than or equal to 27. And then I have to divide by negative 6. And remember, when you have an inequality and you're dividing, you have to change the sense of the inequality. You got to turn it around. There's going to be a 3 that cancels out, so I have negative 5 halves. This has to turn around. X, that one's got to turn around. And then a 3 goes in there, 9, so minus 9 halves. Is that right? I'm looking at this, does that make sense? Hold on a second here. So you've got a 3 that reduces and a 2 that stays. So that's minus 4.5. And this one, yeah, that makes sense. I was seeing this as negative 2.5, and I'm like, no, wait a minute, why is there a bigger negative? And that's just because of the inequality pointing, so I'm okay. All right. I was just brain cramping, thinking it didn't make sense. If you thought of it on a number line, negative 4.5 has to be on the left, negative 2.5 has to be on the right, and you're saying x is bigger than it or equal to, so you're shading this way, and this says x is smaller than or equal to negative 2.5, so you're shaded that way. So you're shaded between, everything's cool. All right. I was just looking ahead and going, oh, wait a minute, there was a problem, but the problem was me. All right. When you have an absolute value equation or inequality, remember you have to set up two different problems. The first time, just take the absolute value bars off and write what's there. Then you have to set up an entirely second problem, a brand new one, turn the inequality around and make what's on the other side negative. And then you solve both of them. Okay? So add the 9 over, divide by 2. Oops, I don't know why I wrote 3. I apologize. There we go. Add the 9 over, so plus 9, plus 9. So you have 2x less than or equal to 6 divided by 2, and you get x less than or equal to 3. Okay, now this one, if you looked at it on a number line, is saying 6 equal to, so it's shaded to the right. That's saying 3 equal to, so it's closed, shaded to the left. X is smaller. When they're shaded away from each other, it's or. So you'd write, excuse me, it really doesn't matter which direction it goes, meaning which one you write first. Traditionally, this one's going to go first because it's the one on the left, meaning it's the smaller number. But there's nothing wrong with writing it this way. Okay? The word or needs to be between them because they're shaded away from each other. All right, let's try this one. Take the bars off. Take the bars off. Turn the inequality around, make what's negative. Subtract the 6 on both of them. Divide by negative 3. Oops, and because I divided by a negative, I got to turn the inequality around. I almost missed it. Equal to negative 1. This one, divide by negative 3, x less than or equal to 5. Now when you look at that on a number line, there's negative 1, there's 5. They're both closed circles because they have an equal sign. This one says greater than negative 1, so you shade it this way. That one says less than, so you shade it that way. So you shade in between. So that's an and. And you guys have an option to write your answer this way with the word and. The other way that you're allowed to write it is x is between these two numbers, and you're saying you're larger than or equal to negative 1, but you're at the same time less than or equal to 5. So this is one way to write it. This is the other way that you can write it. And I tried really hard not to use the word or there because I wanted you guys to, write it this way, and the other way is that way. Okay, because I didn't want to have you guys hear the word or in that. All right, ors are when they're shaded away from each other. Ands are when they're shaded at each other. So how do you know which one it is? Well, do a little graph and look at it. Okay, and then you know if it's and or. 3x minus 5 greater than 1, 3x minus 5 less than negative 1. And you solve them both. 3x, add the 5, so that would be 6. X is greater than 2. Add the 5, divide by 3. Stick it on a little number line, take a look at it. There's 2 open circles shaded right. That's 1 1/3. So 4/3, so it's on this side, that's a 4. Open circle shaded left, so that's an or. So you'd have x less than 4/3 or x is greater than 2. Okay? I think that's it. It's the last page, isn't it? Yep. So there you go. Review for Chapter 1.